Here is another example of the inequalities at FP2. We've got x squared plus 7x plus 10 over x plus 1 is strictly greater than 2x plus 7. X could not be equal to negative 1. Whilst it looks favourable to factor this numerator, there's really no point. All we need to do is multiply through by the denominator squared, as we've discussed in the last two videos. If I do that, what I'm going to have is x plus 1 squared multiplied by x squared plus 7x plus 10 all over the x plus 1 is going to be greater now than 2x plus 7 multiplied now by that denominator squared of x plus 1 all squared. As stated in the last couple of videos, this really isn't required. You can just simply write it now as x plus 1, and then we've got x squared plus 7x plus 10 is going to be greater than now 2x plus 7 and then x plus 1 squared. I'm going to set the left hand side equal to 0, so we'll have 0 is going to be greater than now 2x plus 7 multiplied by x plus 1 squared minus x plus 1 multiplied by x squared plus 7x plus 10. We're now going to factor this. So if I factor it, taking the common factor of x plus 1 out, we're going to have 0 is greater than x plus 1. Now this is going to leave me 2x plus 7 multiplied by x plus 1. So 2x plus 7 multiplied by x plus 1. And then we're going to subtract away the x squared plus 7x plus 10. Hopefully you can now see why factoring that would have been pointless anyway. We can see that the 2 and the 5 are not going to be common factors. Therefore, we would just end up expanding that back out. So let's do this then. So what we're going to have is x plus 1. This is going to give me 2x squared plus 7x plus 2x plus 7. So we get 2x squared plus 9x and then plus 7 minus x squared minus 7x minus 10. So just tidying up in that bracket now, we've got the x plus 1 outside as the common factor. We're going to have x squared, we're going to have plus 2x, and then we're going to have minus 3. So factor in the last bit, the quadratic will factor. So we got x plus 1, and then we got x, what's that going to be, x plus 3 and x minus 1. So if we now write a function, and we'll put it up here, we'll write y is equal to the product of the linear factors of x plus 1, x plus 3 and x minus 1. We've got the critical values to look at of minus 3, minus 1 and then 1. So let's sketch this graph up now and look at this. That's a positive cubic, so let's draw that up, and we're going to have a solution just here at minus 3, 1 at minus 1 and 1 at positive 1. So it will be looking something give or take like so. This doesn't have to be hugely accurate. That's minus 3, that's minus 1 and that's 1. We want to go back to this and decide where all of this is strictly less than 0. So if we look on the graph, we can see that it's going to be less than 0 this side of negative 3 and also in this part right here. So all we need to do to finish is state the regions that satisfy this inequality. So minus 3 is greater and strictly greater to x, greater than x I should say, or x is going to be strictly greater than minus 1, yet in turn strictly less than positive 1. So these are the regions that satisfy our inequality. On that one you could have gone the other way and you could have subtracted, so which way did I go? I went to the right. You could have subtracted this from the left and you would have ended up with a negative cubic, and then you would have sketched a negative cubic. I prefer going to the right. By the looks of that one we were always going to end up with a positive cubic rather than a negative cubic, because it then throws in an additional bit of work, but hopefully that will give you some idea on how to solve it, and there are our values.